Okay, so let's look at question 4. It says two blocks of masses 10 kg and 4 kg are connected with a light inextensible string and placed on a horizontal surface. When a force of 58 Newton is applied to the 10 kg block at an angle of 25 degrees with the horizontal, the system accelerates at 2.72 meters per second square. So we are given the acceleration to the right as shown on the diagram below. The 4 kg block experiences a constant frictional force of 2.5 Newton. So we are given the frictional force of the 4 kg block. Then 4.1 says, state Newton's second law of motion in words. So let's run quickly to that. So we say Newton's second law states that when a net force is applied to an object of mass, the object will accelerate in the direction of the net force, where acceleration is directly proportional to the net force and inversely proportional to the mass of the object. So this is how you are expected to define Newton's second law of motion. Then 4.2 says, draw a free body diagram of all forces acting on the 10 kg block. Now to draw that one, let's have our forces. So this is on a surface. That means it has the normal force, and then we know that acting downward is always your gravitational force, and then it is being pulled by a string connected to this 4 kg block, so we have tension here. But then this 10 kg block experiences the frictional force obviously in the opposite direction of motion, because frictional force opposes the motion of an object. Then we can see that a force is applied at an angle like that. So we can just indicate the angle is 25 degrees. And then here we have our force applied. So this is our free body diagram. Remember, we said there are two ways in which you can draw this free body diagram. It's either like this, whereby you don't resolve the force applied, or you can draw it like this. Now, preferably, I like the one whereby you resolve, because it also helps you in terms of your calculations. You get to see all your horizontal forces and your vertical forces, right? So now we are resolving fx and fy like this, because this is in the first quadrant. So fy goes up like that and fx goes horizontally like that, and then this is our fy, and then down here we still have our usual forces fg, and then we have tension here, and then we have the kinetic frictional force. So whether you draw this one or you draw this, you should get your full marks, 5 marks. So do not be confused here to think that this one deserves an extra mark because you have 6 forces. Remember, these ones are marked as 1. So Fy and Fx, they all represent your force applied. So yep. Then 4.3 says calculate 4.3.1 the tension in the string connecting the two blocks. So what are we given? We are given the acceleration, and then we are also given the frictional force experienced by the 4 kg block. Now, in order to successfully answer this one, we would need to know all the forces that are involved in this 4 kg block. So we can just indicate the forces. We have the Fg, and then we have obviously the normal force, it's on the surface, and then we have the tension, and then opposite here, the direction of motion, we have kinetic frictional force. So now to calculate the tension, we can even see it's only for 4 marks, right? So this is not the one that requires simultaneous, because remember, we are given acceleration. With the one that requires us to use simultaneous equation, usually you do not have tension and you do not have acceleration. Remember, for simultaneous you need 2 unknowns, but then for this one you only have 1 unknown, which is your tension. And then we can pretty much see that we can calculate it easily with just using our 4 kg block. So now we will say for 4 kg block, so using the 4 kg block, can calculate the Fnet. Fnet is equals to mass times acceleration. Then what do we have? So we have our tension minus the kinetic frictional force, and then m times a. So remember, where the object is going, we take it as the positive direction, and then the direction that will oppose the motion, we take it as negative direction. Hence we have T minus Fk. So the tension is positive and Fk is negative. Then what is our tension? That's what we are looking for. But we were told that the Fk is 2.5 newtons, right? And then the mass is 4 kg, and then the acceleration is 2.72, right? Then calculating this one, we can start off by multiplying 4 times 2.72. So we will have 10.88, and then add it to 2.5, and then our tension is 13.38 newtons, right? And just like that, we have our 4 marks. Then 4.3.2 says calculate the coefficient of kinetic friction between the 10 kg block and the surface. But then remember, we already have the free body diagram for that. And then remember, the free body diagram to use for that one is this one. This one is better because remember, it has all the horizontal and vertical forces clearly shown, right? Then remember, when it comes to Fx, to Fnet, I meant to say, when it comes to Fnet, we only use the horizontal forces, right? So here we have Fx, Fk, and tension. Now you see the problem with using this one is that now you do not know if you should include this one or not, and then whether you should include it as Fa like that. So now this one, but with this one it is pretty clear because you can see the Fx is here and then Fk and tension. But then remember, Fx is indicated as the force multiplied by cos theta like that, right? And then we are required to calculate the coefficient of kinetic friction. So let's start with that. Let's start with the calculation. So we will say for the 10 kg block, we have Fnet is equals to MA, and then we have Fx minus tension minus Fk is equals to mass times acceleration. Note that the Fk that we had for 2.5 is not the one that is experienced by the 10 kg block. So they might have the same acceleration and the same tension, but they do not experience the same kinetic friction, right? Then to calculate this one, Fx, we know it breaks down to F cos theta minus tension, and Fk, we know it breaks down to mu k times n. Now do not be confused by this question. Here we are required to calculate Fk, right? So let's do it like this. Let me first calculate Fk, and then we'll break it down. We can substitute in our Fk like this, and we start by calculating Fk. So what is the force there? It's 58. So we have 58 cos, and then the theta is 25 degrees minus the tension. Remember, tension we've already calculated is 13.38, and then we'll say minus Fk is equals to the mass is 10, and then here we have 2.72. The acceleration is all the same. Then let's calculate our Fk. Can just punch all this in a calculator. So we have punching all this, we have 39 point. So I do not want to round off to 2 decimal places as yet. So it's 39.1859, and then minus Fk is equals to 27.2. So now calculating the Fk will have, okay, so calculating for Fk will have negative Fk here, and then we can transpose all this to this side, and then this will become negative 11.9859. Then we can just divide both sides by -1, and then Fk becomes 11.9859. But then you will remember that we are not looking for Fk, we are looking for the coefficient of kinetic friction, which is mu k. Now Fk can be broken down to mu k multiplied by the normal force, right? Now consulting our free body diagram, we can see that the normal force here, the Fn, can be indicated as Fn plus Fy is equals to Fg. So now if we are looking for the normal force here, we must make it the subject of the formula. Therefore, the expression for the normal force will now be the Fg minus the Fy, right? So note that whenever we are pulling something, it is always the gravitational force minus the vertical component of the applied force. So now we will have Fk is 11.9859. Then we have our mu k here. Then the normal force is the gravitational force minus the vertical component of the applied force. But then note that Fy can be broken down to F sine theta, right? So we're just going to substitute it here. So it's 11.9859 is equals to mu k, and then our Fg is mass times the gravitational acceleration, which is 10 times 9.8. Then so let me write it neatly for you. Okay, so now we have 11.9859 is equals to mu k, and then when we punch all that in a calculator, we have 73.49. Then we can divide both sides by 73.49. Divide both sides by 73.49, and then our mu k becomes 0.16. Okay, so now we have 4.4. It says the angle at which the force is applied is decreased to 15 degrees. How will the answer in question 4.3.2 change? Write down only increases, decreases, or remain the same. Explain your answer. We will say the answer to that one is remains the same. Why? Because we say the coefficient of friction can only be changed by changing the surface. Right.